experimental spectra S of any of the peptide P, that is from P1 to Pn, is considered complete if it has the specific ion corresponding to the N terminal. And we know that the value of that spectra will be 1 is less than or equal to I and I is less than or equal to N. And we also know that that specific spectra has a specific path, and the value of that path is N plus 1, and that starts from S initial to S final. And that spectra is used to find the correct path of the experimental peptide sequencing problem. And we know that the good path will be that path which has the maximum number of the vertices. And we also know that most of the spectra, they are incomplete. And if they are incomplete, they generate many of the paths that have the sizes that are larger than the most of the smaller sizes. And these larger sizes paths, they are used to find the best one, and it removes the ambiguity between those large paths that are present in those spectra. So the problem with choosing the path with the maximum number of edges is that it does not adequately reflect the importance of different vertices. For example, the vertex in the spectrum graph obtained by the shift of +1 as Si +1 should be second higher than the vertex obtained by a shift of rare water to the ammonia ion. And we know that the mass will be S1, 1 minus 18 is equal to minus 17. That will come out to be minus 34, because we know that 18 is the mass of the water and 17 is the mass of the ammonia, and it comes out to be 34. So further, whenever there are two peaks, S1 and Sj, so Sj plus S delta J is equal to Si plus delta J. So the vertex corresponding to that mass should also get a higher score than the vertex obtained by a single shift. In the probabilistic approach for the generation of the peptides and the ions, there is a probability by which these ions are generated, and they are represented by the P for probability and the delta I. And the probability that the delta I will be generated by any of the peptides is independent of the generation of the delta J that is generated by the same peptide. So these peptides that are generated by the same peptides, the ions are generated by the same peptide, they are independent of each other. So under this assumption, any given partial peptides may contribute as many as k masses in the spectrum, and this happens with probability and as few as 0, and this happens with the probability with 1 minus p delta ij. So the probabilistic method below scores the vertices of the spectrum graph based on these simple assumptions.